Okay, grade 8. This is your PR2 isolating variables review uh, on uh, on algebra. The questions, there are 20 questions in total, 4 true, false, and a whole bunch of other questions. So we're going to start with your true, false. It says, so the question number 1 says, negative 2 multiplied by x minus 3 equals 10. The constant is 6 when expanded. Now, the when expanded is pretty important for you to remember. When I put that there, it's for those people who forget to expand distributive property. Because technically on a test, I could just say the constant is 6. And in this true false, a lot of you are going to say false because you think the constant is negative 3 because it's right here. You remember that the constant is the part of the equation that is the plus minus part, and it appears to be a minus 3. But in fact, it is a positive 6. So what I'm going to do is I'm going to expand it using distributive property. Negative 2 times x will be negative 2x. And a negative 2 times a negative 3 is a positive 6. So when I expand this equation, I end up with negative 2x plus 6 equals 10. And the constant is plus 6, so the answer to the first question is true. The constant is positive 6. Question number 2 says the coefficient in this equation, the coefficient is 0.4. The coefficient is 0.4. Now remember, 0.4 as a coefficient, if this equation was written with a 0.4 coefficient, it would look like this because the coefficient is the multiplier of the variable. And the answer for this is false. It's not. And what you would have to do to show me what you knew it was, you know that this is a quarter of x. So if I was to draw it modeling-wise, that's what it looks like. Or a quarter of x in word form. But the most important form to write it is a quarter of x. Now you can write it either this way or this way. So technically, if I asked you what is the coefficient in the expression x over 4 or a quarter of x, the coefficient is really 0.25 or a quarter. Right? Sometimes people think it's 4 or even 4/10. But in order to do that, you have to show kind of this stream of thought to prove that you understand that the coefficient or the multiplier is really 0.25 because you want a quarter of x, not all of x. In the third true false, it says in the equation negative 2 equals 4x minus 3. The most efficient first step is to add 2 to both sides. The answer for this is false. Adding 2 to both sides is not efficient because what happens if I add 2 to this side and I add 2 to this side, I end up with 0 equals 4x minus 1. And then I'm like, hold on, my goal is to get x by itself, and I didn't do anything. I still have a coefficient and a constant, so I would then go, oh, I screwed up there, so I'm going to have to add 1 to both sides. Now I get 4x equals 1. I'd have to divide both sides by 4, and x would equal 0.25. So can you add 2 to both sides? Yes, you can, but it's not efficient because what you end up doing is adding an extra step that's not necessary. So it is possible to add 2 to both sides. You could actually multiply both sides by 100 if you really wanted to, because whatever you do to one side of an equation, as long as you do to the other, you maintain equality. But the most efficient, the answer is, what is the most efficient first step? The most efficient first step would have been to add 3 to both sides. And in doing so, you got rid of your constant, and then you could take it from here and be able to get your answer of x equals 0.25. And finally, the fourth question on your practice test, it says when x is negative 2, the expression negative 5x equals, or sorry, negative 5x minus 10, this expression negative 5x minus 10 would equal 0. Is this true or false? If x equals negative 2, does this expression equal 0? So when you are given a value for a variable, what you have to do is you have to substitute it in to where the variable was. This is negative 5x, which means negative 5 multiplied by the value of x, which is defined for us as being negative 2 minus 10. And if I simplify this using BEDMAS, I should get 0. Negative 5 times negative 2 is a positive 10, and a positive 10 take away 10 is 0. So therefore, is it true? Yes, it is. It is a true statement. When x equals negative 2, that expression will equal 0. Okay, now your next questions are isolate the variables using opposite operations. So the first equation gives you this. So when you show your work, you have to show your work properly. In order to get rid of a 5, I'm going to subtract 5 from both sides. X equals the sum of 2 and negative 5, which is negative 3. So on your test, if I don't see the negative 5s underneath there, and I don't see the line, I don't see the x equals, and it's somewhere above it or below it or to the left or to the right or somewhere where it shouldn't be, you're going to aggravate your teacher and you'll probably mark it wrong. Do not do this. Why? What does that mean if I put a line there? That means division. So don't unnecessarily put a division sign in there when you simply mean to add and subtract 5 from each other. Some of you are adding superfluous division signs when you shouldn't have them. In the second question, it says negative 5x equals 5. So here we have a coefficient of negative 5, or a multiplier. Here I'm going to divide both sides by negative 5. And I'm going to have a solution of x equals negative 1, because a 5 divided by 5 is 1, and a positive divided by negative is a negative. In question 7, you have negative 5 equals x divided by negative 2. So again, the only difference between this question and the last one, well, several differences, but the main difference is your variable is on your right. So here I'm going to get rid of dividing by negative 2 by multiplying by negative 2. I'm going to do so on both sides. X will equal the product of negative 5 and negative 2, which is a positive 10. That's question 7. Question 8. Question 8 says negative 3 equals negative 4x. So the variable again is on the right. I want to get rid of a multiplying by negative 4, so I'm going to divide both sides by negative 4. X will equal, well, 3 divided by 4, I know is a fraction in 3/4, so it's going to be 0.75. And a negative divided by a negative is a positive, so the answer is x equals 0.75. Question 9, negative 3x plus 9 equals negative 6. Now we have in two-step algebraic equations. And don't forget, when you have a two-step algebraic equation, the first thing you can get rid of to make it the easiest or the simplest way is the constant. So here I'm going to get rid of the constant by subtracting 9 from both sides. Negative 3x will equal negative 15, which is the sum of negative 6 and negative 9. I'm going to divide both sides by my coefficient, negative 3, and x will equal a positive 5. All right, try this one. Question 10 says 10 minus 2x equals negative 20. So again, in this particular case, your constant, you're going to identify your constant easiest if you draw this. So this is positive 10. This is negative 2x. And this is negative 20. And when I draw it out, on the side of my variable, the constant will always be that part, which is the plus or minus term. And in this case, I see that that plus or minus term is going to be a positive 10. So once I've identified that the constant is a positive 10, I know to get rid of it, I'm going to subtract 10 from both sides. Now, a lot of people put 2x next, but it's not negative. It's not 2x. It's negative 2x is left, equals negative 30. I'll divide both sides by the coefficient, and x will equal 15. In question 11, we have negative 1 equals 5 plus a negative third of x. So again, this time your variable is on the right. Your constant happens to be the first term again. So the first thing we're going to do to isolate is to get rid of that constant, which we've acknowledged is 5, by subtracting 5 from both sides. So that's going to leave me with a negative third of x equals a negative 6. Okay? And once we do that, we know that this says x divided by negative 3, and I know I have to do the opposite operation to get rid of that. So I'm going to multiply both sides by negative 3. That's going to get rid of the dividing by negative 3, isolating it to x, or getting x by itself. And x equals the product of negative 6 and negative 3, which is a positive 18. So therefore, x equals 18, or 18 equals x. Some students want to flip it around and put the x on the left. Don't do that. If the x is on the right, keep it on the right. I know it doesn't affect the answer, so if you have x equals 18, that's fine. but just keep it where it is. Just keep it on the left or the right or wherever you have it. I like it better that way. In question 12, we have a two-step algebraic equation that's in a more standard form, something we're more accustomed to seeing. You know, a variable, a fractional negative variable, plus a constant of 2 equals negative 1. So the first thing is to get rid of your constant. I have this. Get rid of your fractional coefficient by multiplying both sides by negative 8. And I end up with x equals the product of negative 3 and negative 8, which is 24. The next question. Holy snap and Archibalds. In 2 words, if I ask you to describe what kind of algebraic equation, this is an algebraic equation that utilizes what? 2 words. Distributive property. If you do not acknowledge this is distributive property, you are going to have problems with many questions on the test. The first thing you have to do is realize I have to multiply both of those terms in the brackets by 2. There are so many students who get this wrong that do this first. It is not a constant of minus 7. And you have to acknowledge you have to expand it first to identify what your constant is. When I expand it, I see it's not a negative 7 constant, it's a negative 14. So in order to get rid of the constant, I have to add 14 to both sides. Once I have that, I'll get x equals 1. There are still many people on the planet who believe 2 divided by 2 is 0. But $2 divided between 2 friends, if you both get nothing, the $2 ceases to exist. $2 divided between 2 friends is $1 each. Okay? Now there is an alternative that you could have done with this. You could have taken this question and much more simply divided both sides by 2. So instead of having 2 groups of x minus 7, you have 1 group of x minus 7 equals negative 6. And by doing so, you still end up with the same answer of x equals 1, just a much simpler way to get the answer. Question 14 is the exact same thing. This time, it's distributive property, but your variable is on the right. So the same process has to happen here. The constant's not negative 1, for God's sake. It's negative 2x plus 2 equals negative 4. Now you see that your constant's not negative 1, but rather positive 2. To get rid of it, you're going to subtract 2 from both sides. Negative 2x equals negative 6. Divide both sides by the coefficient, and Bob is your uncle. Negative 6 divided by negative 2 is a positive 3. Bob's really your uncle? Interesting. Yep, I'll press pause. Last question. So we have question 15 in the back. And it gives you this question right here. It says 3 is the width, and x plus 6, or length, and x plus 6 is your width. And it says the area equals 25.5 units or meters or whatever it happens to be. What is the perimeter? So for this one, I know that I'm going to write my formula, and I'm going to substitute all of the information I have. The area is given to me. The length is given to me. The width is given to me. So length times width equals area. Now I have an algebraic equation that utilizes distributive property, that if I solve for x, I will know the length of this. And not only will I know the length of it, I will be able to calculate the perimeter. So the first thing I'm going to do is expand. So 25.5 will equal 3x plus 18, because 3 times 6 is 18. I'm going to subtract 18 from both sides. This will equal 7.5. Because a positive 25.5 take away 18 is 7.5. Then I'm going to divide both sides by 3, and x will equal 2.5. Okay. Now that's not done. We're not done at all. We just solved for x, which is important. Because once we know x is being 2.5, once we know that x is 2.5, I can erase that x and put 2.5 right there. And instead of having 2.5 plus 6, since this now has numerical values, I can erase that whole thing and put the value 8.5. Because x plus 6, since x is 2.5, then that distance has to be 8.5. And now the perimeter is fairly simple. It's 3 plus 8.5 plus 3 plus 8.5. That's going to be 11.5 doubled, which is 23 meters or whatever it happens to be. Okay, so or is that right? No, 11 and a half. Yeah, 23, right? 23. Yeah, the perimeter will be 23. So there's a few steps you had to do there. Make sure if you struggled with it the first time through, watch it again tonight, because there is a question like that on the test. Question 16 gives you a triangle. Gives you a height of 5, a base of x plus 4, and an area of 20. So again, base times height divided by 2 equals your area. Area is 20. The base is x plus 4. The height is 5. I'm going to keep my monomial, my 5 first. And I'm going to divide that by 2. So base times height divided by 2 will be 5 times x minus 4 divided by 2. Here I'm going to get 5x minus 20 when I expand it, divided by 2 equals 20. All right. Now, there's different ways we can do it. So what I'm going to do is I'm going to multiply this side by 2 to get rid of half of that, and I'm going to multiply this side by 2. So what I'm going to end up with is 5x minus 20 equals 40. All I did was I doubled both sides. Instead of having half of 5x minus 20, I'm going to have all of 5x minus 20. And since I doubled the left, I have to double the right. Now I'm simply going to use my grade 7 algebra skills. 5x equals 60. And when I divide both sides by 5, x will equal 12. Okay? But we're not done. Again, since we now know that x equals 12, I can substitute it in here. And instead of being 12 minus 4, that's going to tell me that the base of this is 8. And the perimeter will be 5 plus 8 plus 13, which is 13 plus 13, which is 26. I think. Is that right? Did I make a mistake? We good? Okay. And your last questions on your test are your modeling. I'm just going to do 2 of them because I'm going to tell you which 2 are on your test. Questions 18 and 19 are on your test. So we're going to do the first one, 4x minus 1 equals 3. To model it, you need 4 x's, and a minus 1 equals a positive 3. That's what this equation says. So the first thing I'm going to do is get rid of my constant by adding 1 to both sides. My next picture will be 4 x's equals 4. And if 4 x's equal 4, then each x must be 1. And therefore, the solution to my equation is x has to be 1. So throughout the whole modeling process, nothing was answered numerically until the very end when you isolated x, and x had a value of 1. Since 4 x's were equal to 4, then each x was equal to 1. And finally, the last question I'm going to do with you is question 19. Negative 2 equals negative 5 plus a fifth of x. So when I draw this, start with your scale with your equal sign. Both sides are equal. Negative 2 equals negative 5 plus a fifth of x. So that's what the starting picture looks like. My constant is negative 5, so I'm going to add 5 to both sides. Whatever you do to one side, you have to do to the other. My next picture will be a fifth of x equals positive 3. Now, if a fifth of x equals positive 3, then if I had 5 of these, or quintupled this side, I think quintuple is a real word. If I quintuple this side, I have to quintuple this side. There's doubling it, tripling it, quadrupling it, quintupling it. And all of these together, if I stack them all together, are going to make a full X. And over here, 3, 6, 9, 12, 15. And therefore, X has a value of 15. Yes. I kept numbers so it's not too big, yeah. Any questions? Are we good? Just leave it.